Section 8.3 is going to continue with from that mini investigation with parabolas and graphs of the quadratics. And so the mini investigation showed you the effects of A, B, and C and a combination of them on the actual movement of the graph and what the graph it compares to with the mother function. And so these next slides, if you look at these slides here, we've already covered. We covered these in the mini investigation. So if you've not gotten these, you could write them down, but you should have these from your mini investigation. So the effects of C, which is your y-intercept, and the effect of A and B have on that graph, and that is where you're going to have that shift of that vertex graph. Number 4 that we saw in that mini investigation. So tonight, this video is just to talk about another way of graphing, the actual graphing it, getting the points that you need to graph it. So if you think of what so you have your parabola, and I'm going to try to draw one here. So here's your parabola. The vertex of that parabola is going to be at that very minimum point or that maximum point. So if you think about uh, your axis of symmetry, and it doesn't matter where, I could put my axes here, it doesn't matter. Okay, so that axis of symmetry is going to go through that vertex. That's the point that makes it symmetric. If you folded it at that point, it would lie on top of each other. So how do we come up with that point? Well, we're going to look at later on, we're going to look at the vertex form of a parabola. Right now we're going to look at just that standard form, and if I write that standard form up here, it's ax squared plus bx plus c. And so to find the x value of that vertex, you essentially are finding that axis of symmetry. And that is when we did the quadratic formula, that's represented by that value right there is the negative b over 2a. And so your vertex point is at negative b over 2a. That's going to give you that point. So that point right there is negative b over 2a, comma, something. So then what you do is you take that point and you plug it back into the actual equation. And so your y value, or the f of b over 2a, negative b over 2a, is that y value. So you're going to take that, plug it back in to get that y value. And we're going to look at that here shortly. We're going to do an example. And so I just said what that axis of symmetry is. That axis of symmetry is negative b over 2a. Remember, it's a line, so you need that x equals. It's a vertical line. So if you just say the axis of symmetry is 2, that doesn't tell me the equation of a line. Make sure you put that x equals in it. So let's look at an example here, and I'm going to show you two different examples because I want to show you something else about it. So here's what my expectation is with your graphing and sketching a parabola. You don't have to plot a million points. What you do have to do is you have to tell me first you're going to say what that axis of symmetry is. So you're going to say axis of symmetry, and you're going to actually find that. And so, and this can be abbreviated AOS if you want. And so again, it's x equals a negative b over 2a, and you're just going to plug those in. So x is equal to a negative 4 over 2 times 1, because a is 1 in this case. So that means x is equal to a negative 2. That is your axis of symmetry. So at x equals negative 2, this vertical line here is going to act as that axis of symmetry. And that's what I want to see. I want to see you go ahead and write that or draw that axis of symmetry in. The second thing you're going to do is now find that vertex point. Well, you've already found the negative 2 part. Now we just need to figure out what is this other part of that. And that's where you take and plug it into the original equation. So you're going to do f of negative 2. And so you're going to have a negative 2 squared plus 4 times negative 2 minus 2. And negative 2 squared is 4. 4 times negative 2 is negative 8. Negative 2. So 4 minus 2 is 2. 2 plus negative 8 is a negative 6. So that means that this vertex point is at negative 2, negative 6. And then you write it as a point. So negative 2, 1, 2, 3, 4, 5, 6 is that vertex point. Now, what I want you to do is you are to just find a third point. Well, if you can plot the y-intercept, you do the y-intercept, and in this case we can, because remember, y-intercept is that value right there. And so we would say, all right, we have the point, we know we have the point -2. And so 0, -2 is here. And then since this is symmetric about this, we can find the symmetric point, which would be this point over here. So that's your other plotted point. And then so your other point is a 1, 2, 3, 4, -4, -2. And that allows now me to draw in that parabola. And this is not going to be real pretty because I don't do a very nice job. I'm just going to do it high. So it comes down, so it goes like this. Okay. So, and it shouldn't be dotted, but so that's what it looks. These are the things that I expect to see. So I expect to see that axis of symmetry. I expect to see that vertex point figured out. And then I want to see a point and the reflected point. Right, so that's what I do expect to see. Now I'm going to show you something else in this next example. You guys do not have this in your packet. You could just watch this so that you can see it. Because this value here is a 1, right, that really is taking the mother function, not making it bigger or smaller, keeping it the same width, but changing where it's going to sit on an axis. So if we think about this, I'm going to show you something here. If I find that axis of symmetry, right, so x equals -b over 2a, and so I'm going to have a negative of a -6 over 2 times 1, which is 6 divided by 2 is 3. So my axis of symmetry in this case is 3. If I go ahead and find my vertex, so if I want to find that vertex, I have 3 comma something, and if I plug 3 back in, so remember you do f of 3, you get 3 squared minus 6 times 3 plus 3. So 3 squared is 9, minus 18 is -9, plus 3 is -6, so it's a -6 again. It comes out to be that way. So 3 -6 is here. There's 3, 1, 2, 3, 4, 5, 6. Okay, so here's 3 -6. Here's your axis of symmetry. Now, what you should know from if you think of your table of values that go with parabola, this is a 1. And so when your A value is a 1, your graph is always from your vertex, your next point's going to be up 1 over 1. So up 1 over 1. And then your next point from that is 2 squared, which is 4. So up 4, 1, 2, 3, 4 over 2. 1, 2, 3, 4 over 2. And we could even do the third one. 3 squared is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. 1, 2, 3. And so if you look, is that your y-intercept? It is, right? Your y-intercept is 3. So that's one thing that you can quickly do a graph of a parabola. If you have a 1, you do 1 over 1, 4 over 2, 9 over 3. If I wanted to do another one, it'd be 16 over 4. But when you have that stretch of 2, then that's going to change. These are going to all change. It's going to make it, they're going to make these points taller or shorter depending on that value. But I just wanted to show you that's another way. I'll try to graph this one. This is another way of drawing, oops, I missed it, drawing a parabola without marking. And so in this case, you can use the point 2, -5, +2, -5, and then the one that mirrors that would be 4, -5. Okay, so that's what you do. All right, go ahead and work at the true false. Well, first of all, when sketching, I have here, you must label the vertex, you must draw the axis of symmetry. You don't have to label these here, you don't have to label the y-intercept, you just need to label 2 points, one on opposite sides, on opposite side of the axis of symmetry. Okay, it doesn't necessarily have to be the y-intercept. If your y-intercept is 23, you're not going to want to plot that point, so you might find another point. So the true false, I made it bigger because I know sometimes they're harder to see. So if you want to use this screen to be able to read your true false, you could do that and you know, use that. If not, you can read it from your paper. Have a good night.